Hello, students. In the previous class, we have seen that what is relations and what are definitions of relations and the types of relations. And we have also learnt about equivalence relation. What are the conditions for a relation to be equivalence? So in this lecture, we will see some questions of exercise 1.1 of NCERT. The lecture is totally focused on your NCERT syllabus. So yeah, we will see that what are the questions in this NCERT chapter 1. Okay. So in exercise 1.1, I will take some of the questions. Due to time constraints, I can take some questions of that. After that, you can solve yourself the remaining one. So yes, let's start. Question one tells us that determine whether each of the following relations are reflexive, symmetric, and transitive. Okay, so we have to tell that whether the relation is transitive, symmetric, or reflexive or not. So here the set is 1, 2, 3, 4 up to 14 number. This is a set of numbers in set A, and relation R is on this set, and relation is defined as x comma y, 3x minus y is equal to 0, meaning that y is equal to 3x is the relation. Okay, so if I have first element 1, so ordered pair will be what? Relation will contain the ordered pair like 1 comma 3, because y is 3x. So when I put the x value 1, it will come as 3. Okay. So y is 3. First order pair is 1 comma 3. Similarly, second order pair will be 2 comma 6. Why? Because when I put the x value equal to 2, it will come as 6. Y will come as 6. Okay. So I have seen that pattern is there. Y is always 3 times of x. So whatever I put in x, the y will become 3 times of that. So here in the third order pair, 3 is the x. So what will be 9? Yeah, 9 will be, sorry, what will be y? It will be 9. Okay. Similarly, if I have 4, so y will be 12, 3 times. So on is the relation. And for like 14, I have what? Here I have 42. Okay. So this is the defined as, but actually it will 4 comma 12, it will be not you can see that 42 is not in the set A. So the set will not go from here, like not go till here. It will terminate at 4 comma 12. Okay. Why? Because after 14 there are no elements in the set A, and the relation is only defined on set A. So this is the all the elements of this set, like relation R, that is what? 1 comma 3, 2 comma 6, 3 comma 9, and 4 comma 12. Okay. So I have to tell that whether this is reflexive. So in this there are elements like 1 comma 3, 1, 3, 2, 6, like that. So can you see that 1 comma 1 is there in the set? No, it is not. Or 2 comma 2 is there? No, it is not. 3 comma 3? No. 4 comma 4? No. So I cannot see the pattern of elements or ordered pair. I cannot see the ordered pair like this. A comma A, that will belong to set relation R. Okay. So the relation must have this pattern of ordered pair to be reflexive. So the relation is not reflexive. Relation is not reflexive. Okay. It is obvious that this relation is not reflexive because I cannot see the pattern of A comma A like ordered pair in this relation. I have already told you about what is the reflexive relation and what is the condition for that. You can see in the previous lecture if you haven't seen that before. Okay, yeah. So I will just clear this part so that I can proceed for next part. Okay? Yeah. Now I have to check that whether the relation R is symmetric or not. It will contain 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 12. Okay. So whether I can see the elements like 1 comma 3, then 3 comma 1, is the pattern following this ordered period or not? No, these are not there. 1 comma 3 is there, but 3 comma 1 is not present in the relation R. So for symmetricity, you already know that if I have A comma B in the belong to relation R, then B comma A must belong to relation R. It is not like following here. So we can say that the relation R is not symmetric also. So the relation R is not reflexive and not symmetric also. Okay. Now I have to check whether it is transitive or not. So here 1 comma 3 is present in the relation R, and 3 comma 9 is also present in the relation R. But can you see the 1 comma 9 ordered pair in the relation? No, not there. So for like transitive, you know that A comma B is there and B comma C is there. So you must have A comma C also in the relation. But it is not there because 1 comma 9 is not present. So the relation is not also transitive. The relation is not transitive also. Transitive. Okay. So the first part is not uh, reflexive, symmetric as well as transitive. So it is all actually not equivalence relation also because it doesn't follow any condition of like reflectivity, symmetricity, and transitivity. Okay. So I will delete all this. Yeah. Now I have told you the first part, and you can similarly do the rest of the parts of this. The pattern is similar to what I have told you in the first example. You can follow this and write the elements of or write the ordered pairs of each relation and can find out whether the relation is like reflexive, transitive, or symmetric or not. So it is a simple task. I hope that you can do all this part in the first question. Okay. So now I will tell you the question two of this exercise. So yes. So what the question two is telling, let's read out. Show that the relation R in the set capital R of real numbers. So there is a relation on a set R only, that is the set of real numbers. The set is defined like relation is defined as capital R is equal to ordered pair A comma B, where A is less than equal to B square. I have to show that is neither reflexive nor symmetric nor transitive. Okay. So first of all, for simplicity, I have to like write some elements or like some order write some order pairs for that, so that I can easily conclude that whether it is reflexive, symmetric, or transitive or not. Okay. So relation R, I will start with some elements like 1. Okay. So if I have 1 comma like you can say that 1 comma 2, you can take the like order pair as 1 comma 2. Okay. Yeah. Then 2 comma 3 you can take. Then you can take other order pair like 3 comma 4. Okay. Yes. Then you can also write here like 1 comma 1 also. So there are infinite like ordered pairs in this relation. So first of all, I have to check that whether it is reflexive or not. Okay. So yeah, if I have like 1 comma 1, is it present in the relation R or not? Yeah, it is present because 1 is less than equal to 1 square. This is true. Okay. Yes. So check whether minus 1 comma minus 2 comma minus 2 is there in the relation or not. uh, is minus 2 is less than equal to minus 2 square. Okay. So minus 2 square is what? 4. Yeah, it is telling that this is true. Okay. Now I will check another number like whether 2 comma 2 belongs to relation R or not. So 2 is less than equal to 2 square. Okay. Yeah, this is following. And if I have chosen a fraction like number, uh, like 1 by 2 comma 1 by 2. Okay. So whether 1 by 2 is less than equal to 1 by 2 square. No, it is not true. It is not true because 1 by 2 is greater than equal to 1 by 4. Is it, this is true for this relation. So you can see that there are some like elements or order pairs which are not following the reflexivity in this relation. So we can say that for for some a or for some a comma a, this like relation R is not following reflexive reflexive pattern. Like for fractions, I can see that for proper fractions it is not following the reflexivity. So it is not a reflexive. I have just proved it. So first part is done, that it is not reflexive. Now I have to check that whether it is symmetric or not. So if I have like one like if suppose that 1 comma 2 is there belongs to relation R, meaning that 1 is less than equal to 2 square. Yeah, it is correct. So if whether 2 comma 1 belongs to R or not, it means that 2 is less than equal to 1 square. No, it is wrong, totally wrong. So it means that relation R is also R is neither following all the elements, R is neither following for all elements or for all ordered pairs. Yep. Symmetricity relation. Symmetricity. Okay, you can see here that 1 comma 2 belong to R, but 2 comma 1 doesn't belong to R. So it is not symmetric also. Now I have to see that whether it is transitive or not. So see, if I have 1 comma 2 belonging to R, okay, this belong to R, we have shown previously, and 2 comma 3 also belong to, or you can say that yeah, yes, like see here, if I have like you can take another example. If I have 1 comma 1 belong to R, this belong to R, and I have uh, minus 1 comma 1, say here minus 1 comma 1 belong to R. This is true or not? Yeah, this is true. And I have 1 comma like 3 belongs to R. This is also true. Okay. So minus 1 comma 3 belongs to R. This is actually correct. We will see another example for transitivity, whether it is following for all elements or all ordered pairs is or it is following or not. Okay. So check for other examples. Suppose I have like uh, minus 4 comma minus 3 belongs to R. Okay. Is it? Yeah, it is true. And minus 3 comma minus 2 belongs to R. Okay. Or you can simply take here uh, like 1 second. Minus 2 comma minus 3 belong to R. Okay. And minus 3 comma minus 2 belong to R. You can take the here like minus 4. Okay. Minus 4 you will take. And now check here what is the relation? Minus 2 is less than equal to 9. Yeah, it is true. And here what is that? Yeah. Minus 3 is less than equal to 16. So for transitivity, I have that minus 2 and minus 4 also in the relation like belonging to R. Okay. For transitivity. So minus 2 is less than equal to 16. Yeah, it is also true. So I have to check for some other examples for transitivity so that I can prove that whether it is following or not. Okay. So yeah, I will take some other examples. Okay. If I take some fraction values 1 by 2 and 1. Yeah. And okay. So yeah, I have to check once. One by two and minus one you take. Yeah. And minus one and minus one and you can take here 1 by 3. Okay. Yeah. So if I now for transitivity, I should have 1 by 2 and minus 1 by 3 in the belonging to relation R for transitivity. Okay. So whether 1 by 2 is less than equal to 1 by 9 for this relation I have squared here. Is it true? No, it is wrong. So I have proved that it is not transitive, transitive also for some elements. Like I have taken here example 1 by 2 minus 1, minus 1, 1 by 3, minus 1 and minus 1 by 3, and then half and minus 1 by 3 doesn't belong to relation R. Okay. So for some elements, the relation R is not following reflexivity symmetricity and transitivity. So the relation is not equivalence also, and we have proved here. Okay, so this is a good question, and I have shown you some example for that. Okay, so now I will solve one more question for from this exercise, and after that we will move forward in the chapter. What are the other topics? So let's do the remaining part. Okay. I hope that you can now solve some questions of like this question two I have told you. So I assume that you can do the rest of the question three, question four, question five. Okay. These are all like similar questions. And six is also like that. Okay. So I will tell you question seven for that. The like now in this next question I will solve in the question seven. Okay. So what is the question seven is telling? Show that the relation R on set A of all the books in a library of a college given by relation R is equal to X comma Y. X and Y have same number of pages is an equivalence relation. So yes, A is the set of all books in a library of college. Set of all books in library. Okay. It is an equivalence relation. I have to prove that it is an equivalence relation. The relation is what? R is the relation that is telling X comma Y. X and Y have same number of pages. X and Y have same number of pages. So it is obvious that if I take a book and compare it with itself, okay, like I have a book of A type or B type. It's A type book. I have A type of book, and if I overlap it with itself only, if I compare it with itself only, so it means that like it contains the same number of pages with it, meaning that if A has 56 pages, so I have A comparing with A is also having 56 pages, so it is must be reflexive. For each book, it will like follow the reflexivity because each book will contain the same number of pages with itself if I compare. So it is reflexive. Okay, the relation is reflexive. Now, if I have two books like A and B, okay, A has 56 pages, B has 56 pages. So if A comma B belongs to capital R, it means that B comma A also belongs to capital R for each A and B. Why? Because if A comma B has the same pages, B comma A should must have with the same pages. Okay, B is also equal to A. So the relation is also symmetric. Symmetricity is following here. Okay. And now I have to show that whether it is transitive or not. So yeah, if I have A comma A book having 56 pages, B book having 56 pages, and if I have in like A comma B belongs to relation R and B comma C belong to relation R, it meaning that A is equal to B and B is equal to C because A having the 56 pages, B has also 56 pages. So B has 56 pages, so C has also 56 pages. It means that A comma C also belongs to capital R for each A, B and C. Why? Because all the three must have the same number of pages. If two having the same pages and two other having the same pages, it must also follow that 1 comma 3 belong to capital R. So it is being shown that this relation is also a transitive one. So I have proved that the relation is reflexive also, symmetric also, and transitive also. So relation is equivalence. Okay. Yeah, this is proof the relation R is equivalent relation. So I hope that you got the point whether the relation is equivalence or not, how to show it. So the question 8 is also similar to that. I hope that you can solve it with yourself. Question 9 is telling that if the multiple of both is this is also similar to the previous one. You have to just write the elements or ordered pairs and you can get the idea whether it is a equivalence relation or not. Question 10 is asking that given an example of relation which is symmetric. So we have to give examples of some relation that are symmetric but neither reflexive nor transitive. Okay, transitive but neither reflexive nor symmetric. Reflexive and symmetric but not transitive. Reflexive and transitive but not symmetric. Symmetric and transitive but not reflexive. So you can cite some examples of relation where there are symmetric but neither reflective. So I will tell you one part. You can further do this other parts. Okay. So I have to show one relation that is symmetric but neither reflexive and not transitive. So suppose that line L1 comma L2, this I have already told you in the previous classes, are perpendicular to each other. Okay. So this is if L is set of all lines, set of all lines, okay, and L1, L2 are perpendicular to each other. This is the relation on this. Relation R is L1, L2 are perpendicular to each other. Okay. So you can easily see that if L1 is perpendicular to L2, then it must follow that L2 is perpendicular to L1. So this is a symmetric relation. But if L1 is perpendicular to L2, so whether L1 is perpendicular to L1 is true. Like if a line L1 is there, L1, is it perpendicular to itself? No, it is parallel to itself or coincident to itself. So this condition is false. So it is not reflexive. Okay, not reflexive. And for transitive, suppose that L1 is like this, L2 is like this. This is L1, this is L2, and this is L3. So here L1 is related to L2, L2 is related to L3 because both are perpendicular to each other. But whether L1 is related to L3, no, because L1 and L3 are parallel to each other. So the relation is not transitive also. So I given you one example of the relation that is symmetric but neither reflective nor transitive. Similarly, you can also try to give some relations which are following the other rules or whether they are transitive or not, reflective or not, reflective or not. You can do the remaining part by yourself. Yeah. So we will move forward. Let's clear this part. Yeah. Now I will solve one like these questions are good. So in 11, 12, 13, 14, I will solve one part for you. That is question 12. So you can see that how it is solved and you can follow that to solve the other questions like 11, 13 and 14. Okay. So let's start. So what the question 12 is telling, show that the relation capital R defined in the set A of all the triangles as R is equal to T1, comma T2. T1 is similar to T2 is equivalent relation Consider the three right triangles T1 with sides 3, 4, 5, T2 with sides 5, 12, 13, and T3 with sides 6, 8, 10. Which triangles among T1, T2, T3 are related? Okay. Yeah. So we have to solve this, and let's try to make the result out of this. So R is a relation defined on all triangles, and R is given as T1 comma T2. T1 is similar to T2. So suppose that I have a triangle like this, R right triangle, and I have one right triangle also. It is larger than first one. So I have the similarity criteria for both these RHS. Okay. So RHS is the like uh, yeah uh, yes, RHS is the similarity criteria, meaning right hypotenuse side is there. So if it is following that one is related to other, so one must be similar to one also for each triangle. For each triangle, they are similar to yours itself also. Okay, like triangle 1 is similar to triangle 1, triangle 2 is similar to triangle 2. This is always true for each triangle. If you coincide any two triangles like this and this, okay, so it is obvious that both are similar to each other. So it is reflexive. First point is true that it is reflexive. Okay. Now I have to show that whether it is symmetric or not. So if 1 is similar to 2 by RHS rule, then 2 is similar to 1 also by RHS rule, by RHS rule only. So it is also obvious that A comma B belongs to, or A comma B belongs to capital R. This implies that B comma A also belongs to capital R for each A and B belongs to A. So this is the relation point for what? For symmetricity. So this relation is symmetric also. Okay. Now the third thing is that whether it is transitive or not. Suppose that this triangle first is similar to second one by Arches rule. Okay. This is similar to this by Arches rule. And suppose that second is similar to third one with the same criteria Arches rule, because you know that the shape must be like similar to third one. So it will also be Arches rule and like similar to the third one. So if I will take like if it is means 3 comma 4 comma 5, and this is like 6 comma 8 comma 10, and this must be like you can say that it will be 9 comma 12 and yeah 15, like this. Okay, so you can see that the ratio between uh, like this, if 3 is to 5 is to 4 is to 5, it similar to, you can say that, once again, yeah, it is similar to um, 6 comma 8 comma 10. Okay, and this is similar to yeah 9 comma 12 comma 15. It is obvious that 3 is also similar to 9 because this is factor of this, means multiplied by some factor. 4 is multiplied by 3, 12. and 5 is also multiplied by 3, 15. So it is obvious that 1 is also related or similar to third one. So for each A comma B, B comma C, it is obvious that A comma C also belongs to capital R. So this implies that relation R is also transitive for each A comma B comma C belonging to capital A. Yes. So it is shown that the relation R is reflexive, symmetric, as well as transitive. So yeah, it is equivalence also. So it is proved here that it is an equivalence relation. And in the second part, it is telling that consider three triangles, that is 3, 4, 5, 5, 12, 13, and 6, 8, 10. Which triangles among one are related? So it is obvious that this is T1 is related to T3 only, and T2 is another type of triangle, right triangle, because 3 is related similar to like 3 is multiplied by 2 and given as 6, 4 is multiplied by 2 and producing 8, and 5 is multiplied by 2 producing 10, meaning that all the three sides are multiplied by 2 factor. So T1 is similar to T2, T3, and T2 is another type of right triangle. So it is obvious that T1 is related to T3 here. Okay. So we can conclude that T1 is related to T3 and T2 is not related to them. So this is the answer for the second part. I hope that you got this question, and I assume that you can also solve the remaining parts of this exercise. And I have told you the major parts of the questions of this exercise. So yeah, let's move further and erase these drawings on these pages. Okay. Uh, Now, in the 15th question, it is telling that let R be the decision set to this, choose the correct answer. So it is a very easy question, and you can do this by yourself because I have told you some examples and what are the conditions for reflexivity, symmetricity, and transitivity. Question 16 is telling that let R be the relation on set N given by this, choose the correct answer. So it is also an easy one. You can do it by yourself. Okay. Similar question whether which I have told you previously. So for till now I have completed your first part of relations and the exercise related to it, and the next topic is like functions and type of functions. I assume that you have already learned about some part of function in the class 11. So for next session, like in the next session, I will briefly tell you what is functions and how these are related to relations and what is the types of functions, operations on functions, and composite functions. I will tell you in the next class. And till now, I hope that you got today's class very well and it was fruitful for you. And yeah, till now, I will conclude this class and thank you and take care. Goodbye. If you have any doubt, you can comment, or if you want any private class or one-to-one session, you can also comment. Okay.